So basically, as you can see, the software is like really simple. It's a really easy software. It's not difficult. For example, when you have problems here, it's easy to solve. That's why it's a good software for power electronics, for what we do. The first thing, you need to start a new project. You can come here on new, but if you guys want to learn more about the software, you can come here to open examples, and you have like a lot of stuff that you can try to see. I know that in Power Electronics 1, you guys will be studying DC-DC converters with pro purpose. You have like a lot of examples. Let's say we want to check the buck converter. You can open the example, and as you can see, like you have something. You can try to run the simulation, and you can try to learn from this. But right now, I'll try to show you like more about the software. The first thing you need to do is like new. You need to have a new project. And this is like the screen we're going to work. As you can see, oops. Yeah. For example, as you can see here, in this session here, you have like some basic elements, like you have a inductor, you have a resistor, capacitor. Like you can find all the like not all the components, like the ones you guys are going to need most. They are here, but if you need more, you come to elements, and here you can find a lot of stuff, like it can be power, control, sources, like it's a really nice software. So let's say we are looking for transformers. You have a section here that you can have like lots of options. Let's say you are working with a motor. Here you have like a lot of them. So you just need to look like for the elements in this section here, and you'll be good. As I told you, I'll try to run a simulation here for you guys so you can see how it works. We are going to do a single phase inverter. We are going to convert a DC source to an AC output. And for this, for example, the first thing that we need is a DC source. We have here a DC voltage source. When you have like 2 clicks on the element, you can change like these parameters. Like you can change the name, which is not important at all, but you can change the value of the voltage. You can have a series resistance or a series inductance. Right now it's better, for example, for the series resistance and these kind of elements, you keep it at 0, so you're gonna have an ideal element. But let's imagine now that we have like a 48 DC bus. Okay, 48. We have 48 volts here. And we are going to do a single phase inverter, a DC to AC converter. For this, I'll be using some MOSFETs because I plan to like switch them on high frequency. So I'll be getting like 4 MOSFETs, and I'll place them here on my schematic. And then to connect the elements, we just need to come here to the wire, and it's really simple. Just click on the component and you drag the mice. See?
Sorry, where's the wire?
It's close to it's here, man. Can you see?
Yeah.
Close to the tag. Here, the wire. Are you guys being able to connect the elements? Is someone having problems? See? You just like, or you can do like 1 click and come.
How do you erase it?
I'll connect all of them and then.
Right click, select and right click. No. Can you select the wire only?
And we are going to have a load. For now, it's going to be just a resistor, okay?
Ask him.
I have a question, how to remove the wire?
Yeah.
If you want to remove the wire, you just need to click on the wire and you can delete it. See?
Press delete. Delete from here.
It's not working.
Any questions, guys? So now we have our converter here. as I told you, we are going to switch the MOSFETs to get some voltage here, some voltage level in the load. If you see here, if we switch like this switch and this one together, we are going to have like plus VDC on the load, okay? And if we switch this one and this one together, we have like minus VDC. So we are getting like an AC level of the load. But for these, we need to do like our switching logic. First, for this, I'll be using a label. So let's say V, 1, and I'm gonna call these like 1, 2, 3, and 4. Okay. As I told you, we are going to like work 1 and 4 together. So let me see it. And we are going to use the same one for this switch. Now for the remaining ones, 2 and 3, we are going to have another label B, 2 and 3. For the label? Yeah, for example, you go to the label and then you just need to enter text. Oh, that is it. Yeah. Here I'm using V23 for like switches 2 and 3, and 1 and 4 for 1 and 4, okay? And then we just need to connect, okay, first, as you guys can see, we are going to connect a label to the converter. So this is not a power element. So for this, we need to use this element here, the on-off switch. You just need to place this in between the label and the MOSFETs, okay? Everyone here?
Okay.
You can put them and then you can use a wire to connect.
Probably this one, yes, this one. It is here like that, but I need to put it.
Oh,
Sorry?
then it is not. Select this one and
Oh.
first you delete all this.
Yeah, guys, also, if you want to rotate,
Delete this.
okay, just give me 1 minute. Let me explain. If you want to rotate an element, you can use the right click, okay, of the mouse. See?
Oh, rotate is right click of the mouse. Right click of the mouse. Select again and right click, right click, right click.
You just need to click on this. You have two options. You can click on the MOSFET and then you can do like this, see? Or you can just take the mouse and like this. Can you click on the MOSFET? Yeah, then you can Guys, to remove something, you just need to click on it and delete. Or if you want to move, you click on the element and you can move like using the mouse or like the Guys, is everyone here at this stage or not? Any questions? Yeah, that's the point. For example, if you see, Guys, in scene, when you are using the software, we can have like power elements and we can have like control or like signal elements. Green lines, they represent like a signal element or like control, and power lines is like power electronics. So if you are going to use something like from green to red here, you need to have these, as I told you, this on-off switch here, on-off controller to convert from like green to red, okay? From signal to power. Is that clear? So we have our converter here. Now we need to, let's say we want to see something. We want to see the currents or the voltage. We need to find the probes for this. We have three probes. We have the current probe, which is placed at like here, can you see? So for these, as you guys might be aware, we just need to place these in series with the element that we want to see the current, okay? Let's say we want to see the current from our DC voltage source. I can come in here, I can delete this wire, I'll take the current probe, and I'll place it in series with the DC source, okay? And for this, I'm gonna call like I DC source. Right click. Right click. No, excuse me. You want to change
Then
that?
vertical.
You can close these.
What is this? It says LT Spice simulation,
Come here now.
run simulation, PSIM simulation. There are two kinds of simulation, and Spice simulation. There are three simulations.
You will show that, bro.
Same view.
Don't worry too much.
File These softwares are linked together, man.
পজ দেওয়া যায় না, এটা পজ কেমন দিই? পজ দেওয়া যায় না, এটা প্রেস করলে এটা চলে যাবে। আমার কাজ মনে হয়।
Get voltage.
I think there is an issue in our source. It shouldn't be like that.
Why do you want to make issues? Like we're not using that. For that point, for example, there's no way to do this. But for example, here you have a signal, like you're going to control your MOSFETs, let's say it's coming from a DSP or something like this, or a computer, I don't know. To make it like, you cannot plug this into your converter. So you need to have something adapt to this signal to the power level. And this is the function of this on-off controller. Okay, so like it does this just to show that, for example, this label cannot be connected here. So that's why we can see the Okay, so guys, for the voltage probes, we have two options. We can have the, let's say, an isolated probe. For these, you have like 2 points. You can take like from whatever you want. Let's say I want to see the voltage in my load with this voltage probe. I just need to connect that in parallel with my load. See? Also, we have another option. We have this voltage probe that's going to measure from the point that you are looking like to see to the ground. Let's say I'm connecting these to the same point here, but then I have my ground. Where's my ground? My ground's here, okay? I'll connect my ground here. Then this probe will measure the voltage between this point and the ground. So we'll be measuring the voltage on this MOSFET. Like, in my opinion, it's better to use this probe here because you can place these like, there's no restriction, you just need to place in parallel with the element that you want to measure, okay? So because I just want to show, I want to show you guys the difference between this one, that's going to measure between this point here and the ground, and this one, which is exactly the same point here. So basically our converter is done. So now we just need to do like how we are going to switch our MOSFETs. We have here these labels, but they need to represent something. Here I'll be doing what we call PWM. You guys are going to learn about this with Prof. Lopez in the next classes, but like for now, we just take these as like something that works, and you guys can see like actually something more. This technique is basically a comparison. So since I want to have an AC level here, I'll take an AC source, a sinusoidal one. Here I'm gonna use like a peak of 5 volts and the 5 volts, and the frequency is like 60 hertz. And for these, I will be taking, for the comparison, I will be taking a triangular wave. For these, I will be like doing a peak to peak as 10 volts, frequency of 25 kilohertz, cycle of 0.5 because I want to have a triangular wave, and the DC offset is going to be -5. As I told you guys, this is just a comparison, so I will use a comparator here, and I'll be connecting these. See that, for example, here, this is like my control of, this is what I'm using to control the converter. So this is a signal, so it's green. It's not red because it's not powered. And for these, I'll be taking, okay, and then from this comparison, I can like turn on or off my switches. Okay, in this comparison, I'll be using the B14, and I'll be getting this NOT gate. For my tube. And I want to see, like, here I'll place 2 probes because I want to see the signals that I'm getting from my converter, okay? So let's say there's something wrong, it's not working, I can try to find the problem. So let's put some probes here to see if it. So this probe here, we're gonna call V14. This one, we're gonna call V22. So for this one, I forgot to do, we are going to use V low. Is everyone here? Do you guys have questions? Like, guys, any questions? Let me see your question.
कोणता लोड बोललो विनाडे मार्क्स केली
This is
হ্যাঁ আমি এটাও ইউটিউবে আপলোড করব, এটাও ইউটিউবে আপলোড করব, যেটা করতে এটা দেখলে বুঝবা।
what is the meaning of this dot? Like this is connector, nothing more than that, right?
Yes. This is connected only.
Yeah, definitely. I have some attributes. I don't know how they set the attributes over here. Need to know dictators. Oh, he used this shit.
You guys have questions here?
Oh, yes, I was looking for
Yeah,
that.
another thing, if you see, you are not supposed to, like, I don't have these black dots in my simulation, see? So something is wrong. Like, for example, if you see here, you had like 2 DC sources at the same point. I don't know why.
Oh my god.
See, here it's the same. For example, see my simulation? Let's just close this.
2 DC. I knew that something is wrong.
See, I don't have these black dots. I have just here when I have 2 wires connecting like each other.
What is the specification of first one?
First one for the sine wave is like it equals 5 volts and the frequency
Okay. Attributes. 5 volts, 60 amps. It's supposed to be 50, I guess. Okay, and for the other one? For the other one? This is not sinusoidal. The other one. I don't know what it is. Frequency. Voltage peak to peak. Yeah. Phase angle. -5. And what did it name? ER1.
Which one is this? Which parameter? Which component is this?
This one.
Okay. This one, right?
This is a sinusoidal.
No, this parameter. This is of which component? This one.
This one is. It is 10. Duty cycle 0.5. 0.5 DC offset Yeah, everything. Which one?
In the middle.
This one?
Yeah.
Didn't do the attributes over here. It's just like no attributes over here. No attributes. This is somewhere. This is a gate.
Marks. This one is marks.
Comparator.
Yes.
Voltage probe. Not gate. What is the use of what is the function of label?
Name only. That's it.
Okay, output you can say, right?
Yeah.
This is output. This is an input, some kind of input.
Yes.
Just label that thing.
Yes.
Why it is not connecting? Yes. Yeah, this is not gate. There is an issue.
So guys, we have these. I saw in some simulations, you are not supposed to have some black dots between like connections. Just when you have like wires connecting to each other, because I'm seeing a lot of you guys doing something like this. You have a DC source and then you have another DC source. You have two DC sources and I don't know why. For example, they're in parallel here. So if you have something like this, if you have these dots here, something is wrong. Like, because then the software is seeing something like this. See? You have like two sources in parallel.
Dot will appear only when
Anyway, I will go forward
wires are getting
and
connected.
show you guys something, and then we are going to try like
not just like that. It also connected if we put two.
Okay,
two
so
sources.
basically our converter is done, our control law here, like our signal is done. Now we go for the simulation. To simulate, the first thing that we need to do is do the configuration for our simulation. You take this block here, simulation control, you come to simulate and simulation control. It's the first element.
Sorry, could you please repeat?
Sorry?
Could you please repeat
Why this thing is
The first thing for the simulation, guys, you need to do the configuration for your simulation control. You come here to simulate this, and you take the first one, the simulation control. And you are going to get these elements here, see? This one.
blocks?
You can open these, and then you have some like elements here. Like the most important is the time step, but first I'll talk about the others. The total time is like the time you want to run your simulation. Let's say you want to run 10 seconds of simulation, but since you are going to do like something like high frequency, it doesn't make any sense. So we can like have, let's say 0.5. 0.5. For the print time, it's like if you want to start saving your data like just at 0.3 or 0.2 or 0, like up to you. If you want to see just a steady state, you can like take here like 0.2 or 0.1. But if you want to see from the beginning, it's 0. Like, and here we have this time step to calculate. Like basically, the time step is like how much points the software will take for each cycle. Since here we are like having like 25 kilohertz as a frequency, our time's like really small. So we need to have like a small time step. For this, I suggest you guys to take like 100 points for cycles. So if we have a switching frequency of 25K, the calculation is 1 over 25K, and this value you can do over 100, and then you have your time step. Okay? Can you guys do this? I don't remember what's the
1 over 25K?
Yeah, I think we're going to get something like, I don't know, 2 or 40 minus 7. Should be like 4 or 5.
Minus 7. Minus 7. Yeah. 40 minus 7 minus 7.
4 minus 7. Okay. So let's run the simulation. I hope it works. To run the simulation, you just need to come here. We have this block here, run simulation. Okay, so my simulation is fine, it's running, as you can see here. And then when the simulation is done, you have this screen here, the sim view. This is like an oscilloscope. It's like you can see all like the things that you are adding, like the probes. You're gonna see here. Yeah.
Not I.
So for example, let's see the V load.
Put I. This should be 1.
This is V load, no?
1E004, right?
So see. I was supposed to get 48. Oh yeah, because I changed the that made it here 48. Let's run the simulation again. Always when you change something, you need to run the simulation again to like to update the results, okay? So for me,
Load.
so let me, for example, now we have these. As I told you, we are doing something like at high frequency, so it's difficult to see. There's no way, but you can have a, you can give a zoom. Like you can come here to this element here, zoom box. You just need to click on this, and then you can have a zoom on your like waveform. As I told you guys, we were expecting something like plus 48 volts on the load and minus 48 volts. So like right now we have something working, okay? Everyone is at this point here. Is your simulation working, guys, or not? No? Okay, let's try to like find out why. Let me go first. This guy does the first from second.
Simulate this. Supposed to be. Supposed to be something like
এটা কত ছিল? কত স্যার কত করেছিল? এদিকে আছে
What is the time step you said? What is the time step?
It has come automatically, right?
Yes.
So keep it like this.
Okay, fine.
আমি স্যারটা ফলো করছি
Easy simulation.
করে গেছিলাম আমি
E1,
Stay here and ask him. Ask Gabriel how to simulate from here.
Where? No, it is automatically. It automatically came. We have already done all the things over here. So from here, I think we just changed the names over here, like V1, V2, V-load. That's all we did. See, V6. This is V6, and V4, V4, V6. One of them is supposed to be load. So we can like do this thing as well. Say
Let me just explain something. Let me see if I have. Bro, I got something.
Ask him.
Okay, I don't have like something here, but guys, for example, for the time step, you need to think that, as I told you, we are doing something at 25k hertz. Okay, so every second we have like 25k repetitions, right? Do you guys agree?
yes.
So we need to be able to see all of these repetitions, like the switching and all of this. So let's say I told you guys, for example, it's good to take like 100 points for these, like to see this, because then the software will take for each repetition like 100 points. Let's imagine you have a sine wave. If you have like 5 points to do your sine wave, you're going to have 1, 2, 3, 4, 5. No, basically you have a triangular wave.
Yes.
So when you have like more points, like more close to the sine wave, you get, right? Yeah. So, but if you add like a lot of points, your simulation will take a lot of time. Like for example, I want to have, I don't know, 1 million points. Your simulation will take like 1 month, because the software, he will be running calculations, like all like over and over again, and you're not going to see anything. So we need to think that like 100 points, like 200 points for each like period is okay.
I'm not sure there's like what did you say the attributes.
Is your simulation working or not?
This is the issue.
Let me see the VP1. Should be there. Okay. Yeah, your simulation is working. You have like, can you give the zoom? No, see, like this. You have the zoom, and you just like, see, you have like plus 48 and minus 48. It was not something that I was expecting. Oh, maybe it's your, see what I told you? For example, maybe it's about your time step, see? For example, if you have more points, you're going to have these like just the, but it seems you don't have like a lot of points, yeah? So he's just going there and coming back. You need to have more points to increase the definition here. I hope this is the problem. Yeah, let's try here. Oh, here it's wrong, but I don't think it's going to.
What is wrong with that one? It's supposed to be sinusoidal, right?
Yeah, but you took the wrong polarity. See, now it's better. I got more points because I went like low from -6 to -7, so, and you have like plus 48 and minus 48. Like here, since it's AC, there's no like problem, but this is wrong. It should be like, you can just do this, like rotate.
Oh,
Now like -2.
thank you so much.
Save the file. All the time, save the file.
Yeah.
Bro, I got
চেক করতে হবে আমার
No. Okay, maybe what you guys were doing, see, you were, yeah, it was right. You guys were checking to see. Then you also for example, we have two rows. Yeah, I removed that row, for example, this one, because you were taking, you have these row here. See, let's say you have these row three. The name is V6, okay?
V, it is some kind of one of the voltage source, I guess. Which one is? You have to select on the voltage sources to know which one it is. It's a V, right? V6 is the main output. V6 is the output.
So installation is working, like, let's just wait for a while.
It's like it's not selecting anything. Thank God. This is the one. Okay, this is the one.
Is it going to show anything more or is done? What do you think? 0.56 is done?
I think that's it. How we have to make the waveforms out of it.
Then I should close the video.
No, not yet. We can't select this one. I don't know how did you change this thing. It's supposed to be. You change the polarity of this one.
ফয়সাল বাংলাদেশ যাইবা ইয়েতে জানুয়ারি ডিসেম্বরে না আমার তো উইন্টারে শেষ হইল আমি তো জানুয়ারিতে যাবো ডিসেম্বরে না ডিসেম্বরে জানুয়ারি সেমিস্টারের মাঝখানে যাবো 10 दिन मिलेगा हाँ
This is the waveform. The interval is very less, like 0.002. This is what I'm. But that side makes it like more big. Reduce it this thing. Is it possible? Yes.
তুমি তো সামার পুরাটা ড্রপ দিছো তো বেশি কোর্স আগে নেই দুইটা মনে না
না না স্টুডেন্ট কার্ড লাগবে।
হ্যাঁ
Awesome. That's it. So now the interval is just 2.2.